Good morning, everyone. Hope you are all good. Okay. Alhamdulillah, I saw some of the notebooks. It's very nice, and some of them that are about 20, some of them that are about 17. So I'm happy with that because the first test you did very well. Okay, keep on going like this. After the second lesson, after this lessons also, I will do some important questions. Just write through it and then read well. Okay. Inshallah, if you have any doubt, come and ask me at any time in the school campus. Okay, when you are coming, please come with a neat uniform as well as the proper haircut. Okay, inshallah. We'll discuss here. We're gonna discuss about that. Kinematics is a motion of an object or motion of the particle without taking the force into the account. Okay. What is mean by equations of motions? Why we are using by calculus method? You know very well, right? What is the velocity? What is the acceleration? What is the time period taken by the particle or object, whatever may be. Okay. When I am taking the motions of the objects or motion of the body, for example, when you are throwing the stone or when the ball hitting after the bat is going in the horizontal projection, or it will goes under the gravity motions, right? So to know all those things, to know the speed and velocity of these particles and objects, we must know all those equations of motion. There are the three relations. The first one we call as the velocity and time relation. The first one we call as velocity and time relations. Okay, what is mean by velocity? The velocity is nothing but rate of change of displacement. The velocity is nothing but rate of change of displacement. But here we are gonna take velocity with time. It's nothing but your acceleration. So the acceleration is nothing but rate of change of velocity. The acceleration is nothing but rate of change of velocity. So here the dv will be equal to a times of dt. The dv will be equal to a times of dt. Now, whenever you are taking the integrations, there is a limit that is called the initial to final. Okay, initial to final. Here we have the velocity. So velocity should have that initial velocity. Let's take u, and the final velocity we take as v. Okay, and also the a will be a non-derivative, so taken as a constant outside. Here we have the dt, which is a derivative process. Here the time 0 to t. Initially the time of the object will be 0. After it is reaching some position, it will become t. Okay, so after taking the time, we can integrate this one. If you are integrating dv, you will get v. You will get v, initial velocity u, final velocity v. And here the a is a constant, take outside. So if you are integrating this one, you will get t. So it will become 0 to t. Okay. So now upper limit minus lower limit. Upper limit minus lower limit. So v minus u will be equal to a t. Minus 0 will become 0. So also we can write this equation v equal to u plus at. U plus at. This is the equation 1. Equation 1. V equal to u plus at. U plus at. This is the equation 1. The relation between velocity and time. Relation between velocity and time. The second one, the relation between displacement and time. The relation between displacement and time. What is mean by displacement? What is mean by displacement? The displacement is nothing but rate of change of no. The displacement is nothing but changing the position or position of an object change according to the time or per unit time. Okay, it's nothing but displacement. What? When object is here, after the sometimes it will moving somewhere, then it is named as displaced. The object was displaced. Okay, so displacement and time relation. You know very well. What is the velocity? Velocity is nothing but rate of change of displacement. Rate of change of displacement. From here, what is the ds? Then ds will be equal to v dt. Now, what is the value of v here? From the equations one, we know that ds will be equal to u plus at into dt. So just multiply inside, you will get ds will be equal to u dt plus at dt. Okay. Now, if you are again, we have to integrate this one. Where are the variables are here? The derivatives process. Integrating displacement 0 to s and ds will be equal to u dt. Okay, so it's a constant integrating 0 to t into dt plus here at Okay, A is a constant, take it also 0 to t, t into dt. So when you are integrating this t into dt, you will get t squared by 2. T squared by 2. When you are integrating this one, you will get s will be equal to ut, because upper limit minus lower limit, plus a t squared by 2. A t squared by 2, because already there is one t and dt. Okay, t squared by 2. So then it will, equation will become s equal to ut plus of at square. Ut plus of at square. This is a relation between displacement and time. Displacement and time. So second equation s equal to ut plus of at square. Ut plus of at square. The third one, the relation between velocity and displacement. The third one, relation between velocity and displacement. Here we gonna take this acceleration in the terms of displacement. You know very well what is meant by velocity and displacement. Okay, velocity and displacement relation. So you know very well, right, about that acceleration. What is meant by acceleration? The acceleration is nothing but rate of change of velocity. Rate of change of velocity. So in terms of displacement, we can write this velocity as rate of change of displacement into change in displacement. Okay, so ds will be cancelled, then what will happen? dv by dt. Okay, so it is nothing but our acceleration. Then a equal to dv by ds into b we can write. Okay, because rate of change of displacement is nothing but your velocity. Nothing but your velocity. Here a will become equal to, when I am differentiating this one, we will get d by 2 ds, d by ds of dv square. Okay, then it will become dv square by ds. Then a will be equal to d by ds of v squared by 2. It will become, okay, v squared by 2. So now we have the relation between velocity and displacement. Take this displacement here. Then displacement will be equal to 1 by 2a, because 2 is a constant and a is also constant, dv squared by dv squared. Okay. Now integrating this one, the velocity displacement have the 0 to s. Here the velocity we have is nothing but what? Velocity, initial velocity to final velocity. Initial velocity to final velocity. So when I integrate this one, we will get s, and here we will get 2a. When I integrate this one, we will get v squared minus u squared. V squared minus u squared. Okay, upper limit minus lower limit. So also we can write 2as will be equal to v squared minus u squared. Or you can write v squared equal to u squared plus 2as. U squared plus 2as. These are the equations of 3. Here the equations are 3. And also we can substitute the values of a here. From this equation we will get the equations at will be equal to, what is that? v minus u, right? v minus u. At squared will be equal to okay, at will be equal to u minus v minus u. So again we will have the t. When you are taking commonly, it will become v plus u t by 2. That's it. These are called the equations of motion. These four are called equations of motion. Okay, why are you using these equations and all? Okay, when you are throwing some objects, when you are throwing something under the gravity, what is the speed, what is the displacement quotient, what is the velocity of the particle, all those things we can came with the conclusion with this one. Okay, when you are throwing some objects, see, when I am dropping this chalk piece here, this goes under the gravity, right? Due to the gravity goes down. So we have to take this. The gravity is acting here, y-axis. Here the x-axis I am dropping. Okay. So when it is going under the gravity, you can take it as positive j. Okay. When it goes against the gravity, you have to take negative j. When it goes in the positive direction, x-axis will take positive I, and here minus I vector. Okay, this is how this is the basis one. And equations of motion at under gravity. Like take, when you are dropping something from the height, which equal to height. Okay, what will happen? The horizontal velocity or initial velocity will become 0 only the object goes through the velocity or speed of acceleration due to gravity. Okay. Now, first, what is the first equation? V equal to u plus at. V equal to u plus at. Here, the object goes under due to the gravity. So, A will become acceleration due to gravity. So, we can write this equation V equal to u plus gt. U plus gt. The first equation under the gravity. The second one, what is that? S equal to ut plus half at square. So, here A equal to g, right? Acceleration due to gravity. And S equal to ut plus half gt square. S equal to ut plus half gt square. The third one, V square equal to u square plus 2as. Here the A. Then A equal to acceleration due to gravity g. So V square will be equal to u square plus 2gs. Okay. This is how the relations will be changes under the gravity. Now, always the initial velocity will become 0, right? Whenever you are dropping the initial velocity u will become 0. When you are taking the u equal to 0, this equation will become V equal to gt, right? U will become 0, so it will equal to 0. I mean gt. This equation will become S equal to half gt square. Half gt square. And here it will become V square equal to 2gs. V square equal to 2gs. Now we have to take the time period of the object. When you are dropping, the initial time will be 0. After some times only it will reach the ground, right? So what is the happen to the time period? When you are dropping something from the height, that height S equal to, we can take as this S will be equal to height. Okay. So that height of the object will be, because from the some height the object is displayed from this height to the ground, right? So height will be equal to half gt square. Now we have to take as a time period. So t square will be equal to 2h by g. Then t will be equal to root of 2h by g. This is the time period taken by the particle to reach the ground. This is the time period to take the particle to reach the ground. Okay. So there is the motion of the body falling from some height, falling towards the earth from some height. Under due to the gravity, it is called free falling. It is called free falling. Okay. The next one is very important. I am from 5 mark also. Okay. The horizontal motion of projectile. Okay. What is that? Projectile. So listen carefully, everyone. What is meant by projectile? Okay. What is meant by projectile motion? Suppose if I throw the object against the gravity, what will happen? What is the first equation? V equal to u plus gt, right? From the equations of under gravity. So, if I am throwing the object against that gravity, what will happen? It goes in the directions of minus j, so it will become minus. Okay, so V equal to u minus gt. Then S equal to ut minus gt square of gt square. And V square equal to u square minus 2as against the gravity. When you are throwing some objects against the gravity, it will become negative. Okay, projectile. What is meant by projectile? What is meant by projectile? When an object is thrown from some height, okay, into the air. See, what will happen? This goes in the horizontal direction. After under gravity, it will go like this, right? See, okay. So I am standing here. When I am throwing the objects, this goes in the direction. After it will fall under due to the gravity. So here we gonna discuss all those things, the horizontal motions and what happened when it's falling through the vertical motions. Okay, here I will draw the line. This is your height. Okay, I am standing here. This is your height of object. When it's thrown from this initial velocity will become 0. After the initial velocity, it will become goes under the gravity. This goes under the gravity. This is your Vx. This is your Ux. And this is your uy, okay, under gravity. This is your range of the particle, distance, okay. This is the height, and here we wanna find all those things, okay. First, you must know what is meant by projectile. What is meant by projectile? when some objects are thrown in air at midway, okay, after some initial velocity, it goes under the gravity. It goes under the gravity. This is called projectile. Action of gravity. Okay. Examples for the projectiles are the object is thrown from the window. Thrown from the train, the rifle, and then what is that? The javelin and the shot put, the jet water from the hole near the bottom of the water tank, the bullet fired from the rifle, all those things are best example for this projectile motions. Okay. So here the projectile in horizontal motion. Okay, the projectile in horizontal projections. Okay, in horizontal. Here we have to take lot of things horizontal motions. First, take this horizontal motion. Okay, take the motion along the horizontal direction. Motion along horizontal direction. Listen, in horizontal we have to take the x-axis, for the vertical we have to take the y-axis. Okay, the first one is horizontal direction. Motion along horizontal direction. Okay, we know that v equal to u plus at, right? U plus at. What is that? The equation of first equations of motion. The second one, s equal to ut plus of at square. The third one, v square equal to u square plus 2as. Now here all the things we gonna learn this one. S equal to ut plus of at square. Here the first one, initially we are taking here the ux. Ux will initial velocity u equal to ux. Okay. Here acceleration will become 0. Here the ux will be equal to 0. Acceleration will be equal to g. Okay, in the vertical motion. Then x is the displacement in the x-axis, so x will be equal to initial velocity u will become ux t plus a will become 0. Okay. A will become 0. So it will become 0. Then x equal to ux t. R in the right, t equal to x by ux. This is the time period. This is the displacement in the x-axis. The second one, motion along vertical direction. So what will happen if the motion along the vertical direction? Y we have to take, right? The y will be equal to, here initial velocity u will become 0, a will become under the gravity g. So y equal to ut plus of at square. U will become 0, then y equal to of gt square. Once the value of t here from the equations 1 we can combine x by ux. Then I can write y equal to 1 by 2 g x squared by ux squared. Here we can take all those things as a common. Okay, next we don't know what is that velocity of horizontal direction. So g by that's it, right? T equal to, right? Then y equal to r g, what is that? X squared by ux squared. If we can write this one g by 2u squared. Okay, this one is a constant. Then initial velocity is also constant. So we can write this one as a k. Y equal to kx squared. The k is nothing but projectile constant. Okay, now we have to find what is the time taken by the particle moving from here to here. The time of flight is called time of flight. Okay, so what is meant by time of flight? The time of flight is nothing but time taken by the particle to reach the ground. From the height. Okay, time taken by the particle from the top of the building and top of the height to reach the ground. It is called time taken. So time taken is nothing but what? We know that height of an object will be equal to 1 by 2 gt squared. From here t will be equal to 2. T squared will be equal to 2h by g. T will be equal to root of 2h by g. This is the time taken by the particle to reach the ground. The next one. we have to calculate what is the range. The range is nothing but how much of distance is covered by the object from the top of the building to the reach the ground. Okay, top of the building to the reach the ground. So range. The range is nothing but distance covered by the object. Velocity equal to what? Distance per time. Then distance will be equal to velocity into time. So what is the velocity here? Initial velocity. So distance will be equal to range will be equal to ux into t. Okay. Ux is nothing but your initial velocity and the horizontal direction. Okay. So that's why we are taking ux and time of flight. So what is the range? Our range will be equal to ux. What is the time of flight? 2h by g. 2h by g. Okay. This is a range that was covered, distance covered by the object to reach the ground. You can also take as the initial velocity or the velocity of the object. Okay. The next one thing we have to find what is the resultant velocity. Resultant velocity. Resultant velocity. What is the total velocity of an object? The total velocity will be equal to root of vx square plus vy square. Okay, vx square plus vy square. So what is the vx? The vx is nothing but your horizontal velocity. So it's nothing but your u. Okay. So what is the vy? The vy is nothing but your vertical. So it is nothing but gt square, right? It is nothing but your gt square. Now, not gt, it's only gt, right? ut, right? Now, the v will be equal to root of u square plus g square t square. U square plus g square plus t square. What is the speed of the projectile motion? What is the speed of the projectile motion? The speed will be equal to, we know that vy will be equal to gt. From here g into 2h by g. Here I can write this g as root g into root g. Okay. Root g into root g into root of 2h by g. So this one will be cancelled and vy will become root of 2gh. So we can substitute here also. V will become root of u square plus 2gh. Because vy will become root of 2gh, then v square will become 2gh. So this amount of speed you will get when throwing from the height of the building. So listen carefully. This is very, very important final question. First you have to find what is that horizontal motions. Okay, you must know what is the projectile motion. When some object thrown in the air, mid-air, it goes with the initial velocity. After that, under gravity is falling down. Okay, this is called action of, due to the action of gravity falling down. This is called projectile motion. Examples are the rifle fired, the bullet fired from the rifle, the water flows from the tank, and then an object thrown from the window side of the train, everything. Okay, so these are the things are very good example for projectile motions. After, first we have to find what is the horizontal direction. What is the projectile in horizontal direction? Vx we have to find. So here an object is thrown, they have the initial velocity ux. Okay, ux will be equal to u. Okay, initial velocity will become u, and final velocity, that means vertical velocity will become v or vx, vy. Okay, now listen. First we have to take what is the projectile in horizontal direction. Vx will be equal to ut. Vx will be equal to ut, and then we have to find what is the x. T equal to x by ux. X by ux. From that we just find that vertical direction y equal to half gt square. Half gt square. Substitute the value of t square there and then find the answer y equal to kx square. After that, you have to find what is the time of flight. Okay, what is mean by time of flight? The time taken by the particle to reach the ground. Time taken the particle by reach the ground. It is called time of flight. Okay, after that, you just consider about the range. T equal to what is that? Root 2h by g. Range. How much of range is covered, or how much distance is covered by an object? Okay, this is called nothing but your range is nothing but your distance. Okay, t equal to v into t. So initial velocity u into t. So it is become 2h by g. After that, you have to find what is the resultant velocity. The both initial velocity and horizontal velocity and vertical velocity. So horizontally we are taking as a u as a horizontal velocity and gt squared as a vertical velocity. Gt will become vertical velocity, so it will become g squared into t squared. From that, what is the speed of the particle to taken? What is the speed is taken by the particle? Is nothing but b equal to u squared plus 2g. Okay, this all the price carries a 5 marks. So read thoroughly and write well in your classwork. Okay, so this is very important or 5-mark question. Next one thing. Turn page number 2.81, 2.36. The train was moving at the rate of 54 km. Okay, 54. The train was moving the speed of 54 km per hour. When the brakes were applied, it came to rest within the distance of 225 meter. Okay, the distance will be equal to 225 meter. It is not speed, it is velocity. Okay. Calculate the retardation produced in the train. So we know, right? V equal to the final velocity of the particle will become 0. The initial velocity of the particle will become 54. So the initial velocity will be equal to final velocity u. Okay, final velocity is brake up. The brake was applied, so it will become rest. Okay, 0. 54 into kilometer. You have to convert into meter per hour. So it will become 5 by 18. Okay, if you are making 5 by 18, what will happen? It will become 15 meter per second. 15 meter per second. This is the initial velocity of the object. So displacement or distance will become 225 meter. Then we know the formula. B square equal to u square minus 2as because it's against the brake was applied. Okay. So u square, what is that? 15 square minus 2 into acceleration due to gravity. 9.8 into 225. That's it. Okay. We have to find what is the acceleration, right? So 2a. So 15 square minus 2a into 225, right? So find that from the answer v square. So v square will become 0. So take out 2a into 225 will be equal to 225. Right? So 2a will become 225 by 225, right? So it will become 1. 2a equal to 225 by 225. So a will become 1 by 2 equal to 0.5 meter per second square. This was the acceleration of an object at the train when its brake was applied. Okay. Okay guys, for this week this is enough because next week I will start with another 5 mark, the oblique motion is called angular motion of the particle. Okay, so it's nothing but the object was thrown from the ground. Okay, from the ground we have to take up. So here also we have the velocity vertical side and then velocity of horizontal side. The negative side of the gravity will take place. So inshallah I will teach that next week. On page number 81, the projectile moves under the combined effect of two velocities. The two uniform velocities in the horizontal direction which will not change provided there is no air resistance. You uniformly changing the velocity, increasing or decreasing in the vertical direction. There are two types of projectile motion. Projectile given the initial velocity in the horizontal direction. The projectile given the initial velocity at the angle of horizontal. Okay, angular projection. Okay, horizontal projection and then angular projection was there. So we discussed about that horizontal projection. Next week onwards we will discuss about this angular projection. Okay, so inshallah we'll see you tomorrow. Take care. Allah Hafiz. Okay, thank you guys so much.